Hello everyone, I am Dr. Jisha Mishra. Welcome to today's discussion of ECL, Ammeter Coupled Logic, l2L Integrated Injection Logic and CMOS, Complementary Metal Oxide Semiconductor Logic Family Characteristics. A digital circuit composed of bipolar transistor that is known for very fast switching speeds. l2L means I squared logic, I square L, CTTL, ECL and bipolar transistor. Ammeter coupled logic ECL is the fastest logic circuit family available for conventional logic system design. A high speed is achieved by operating all bipolar transistors out of saturation, thus avoiding storage time delay, and by keeping the logic signal swings relatively small. Relatively small means about 0.8 volt or less, this reducing the time required to change and discharge the various load and parasitic capacitance. Saturation in ECL is avoided by using the BJT differential pair as a current switch. Now we discussed about the basic principle of ECL. Ammeter coupled logic is based on the use the current string switch introduced in such a switch can be most conventionally realized using the differential pair shown in the figure. The pair is based with the constant current source I and one side is connected to a reference voltage VR as shown in the figure. The current I can be stand in ammeter Q1 or Q2 under the control of the input signal Vi, and especially when V1 is greater than Vr by 4 volt 4 Vt 100 millivolt. Nearly all the current is conducted by Q1. Nearly all the current is conducted by Q1, and thus for alpha 11 V01 equal to VCC minus IRC. Similarly, the current through Q2 will be nearly 0, and thus V02 equal to VCC. Conventionally, when V1 is lower than Vr by about 4 Vt, most of the current will flow through Q2 and the current through Q1 will be nearly 0. Thus, V01 equal to VCC and V02 equal to VCC minus IRC. Figure 1 shows the working of ECL. Now we discuss the ammeter coupled logic features. The features of ECL will make them used in many high performance based application. ECL provides two output which are complements to each other always because the operation of the circuit is based on differential amplifier. This logic family is mainly suitable for monolithic fabrication method because logic level are a function of resistor ratios. ECL device, a differential amplifier design, offer board performance flexibility. So, ECL circuits allow being used both as a digital and linear circuits. The design of the ECL gate has namely high and low input impedance, which is extremely conductive to attending large fan out as well as drive capability. ECL device generates a construct current drain on power supply to simplify the design of the power supply. Now we discussed about the ammeter coupled logic circuit more. The ammeter coupled logic circuit for the inverter is shown in the below figure, which designed with resistor and transistor. In the circuit, the ammeter transistor of two transistors are simply connected to current limitation resistance Re, which is used to avoid the transistor from entering into saturation. Here, the transistor output taken from the collector terminal instead of the ammeter terminal. This circuit provides two output V out inverting output and V out to non inverting output, and the input terminal like Vin where high or low input is given VCC equal to 5 volt. This figure shows the circuit diagram of ECL. Now we discuss about the how does ammeter coupled logic work. The operation of ammeter coupled logic is that whenever the high input is given to ECL circuit, then it will make the Q1 transistor on and the Q2 transistor is off, but the Q1 transistor is not saturated. So, this will pull the V out to output to high. The values of V out 1 output will be low because of the drop within R1. Similarly, when the Vin value given to ECL is low, then it will make the Q1 resistor off or Q2 transistor on. So, the Q2 transistor will not move into saturation. So, it will make the V out 1 output to be pulled high value and the V out T2 output value will be low because of the drop within R2 resistance. Let us see how to transistor Q1 and Q2 turn on and off when a voltage is applied. The two transistors like Q1 and Q2 in the circuit are connected as a differential amplifier by a common emitter transistor. The voltage supplies for the example current are VCC equal to 5, VBB equal to 4, VE equal to 0 volt. The input high or low level values are simply defined to be 4.4 volt or 3.6 volt. Actually, this circuit generates low output or high level that are 0.6 volt higher. However, this is corrected within real ECL circuits. Once Vin is high, then the Q1 transistor is turned on, however not saturated, or the Q2 transistor is turned off. So, output voltage like V out 2 is pulled to 5 volt through the R2 resistor, or it can be shown that the voltage drop across the R1 resistor is about 0.8 volt. So, that V out 1 is equals to 4.2 volt low. In addition, V e is equals to V out 1 minus V q 1 is equal to greater than equal to 4.2 volt minus 0.4 volt. Now, the result is 3.8 volt as transistor Q1 is turned on completely. This figure shows the on off condition of ECL. Once Vin is low, the Q2 transistor will be turned on, but not saturated, or the Q1 resistor is turned off. Therefore, V out is pulled to 5 volt using an R1 resistor, or it can be shown that V out is 4.2 volt also VE equal to V out 2 minus V 0 2 equal to 4.2. So, the result is 3.4. Transistor Q2 is turned on. The ECL, the two transistors are never in the saturation as the input output voltage swings are fairly small like 0.8 volt and the input impedance is high and the output resistance is low. This helps ECL to operate faster with a less propagation delay time. Now, we discuss about the two input emitter coupled logic or a NOR gate circuit. Now, the two input emitter coupled logic or a NOR gate circuit is shown in next slide. The circuit is designed by modifying the above inverter circuit. The modification is by adding an extra transistor at input side. The working of the circuit is very simple. When the input applied at the both the Q1 and Q2 transistor are low, then will make the output 1 V out 1 to a high value. So, this V out 1 corresponds to the output of the NOR gate. Simultaneously, the figure, if the Q3 transistor is turned on, then it will make the second output V out 2 to be high. So, this V out 2 output corresponds to the OR gate output. In the same way, if both the Q1 and Q2 transistor inputs are high, then it will turn on the Q1 and Q2 transistor and provides the low output at the V out terminal. The figure 4 shows the circuit diagram of ECL or OR and NOR gates. Now, we discuss about the truth table of the OR NOR gate is given here. When the A and B input value is 0 0, for the OR gate the result is 0, for the NOR gate its result is 1. When the input is 0 1, for the OR gate it is 0, for the NOR gate it is 1. When the input value is 0 1, for this OR gate is 1 and NOR gate is 0. Now, if the input is 1 0, then the OR is 1 and NOR is 0, and if the input is 1 1, then the OR gate is 1 and the NOR gate is 0. So, this is clear for the table. NOR gate is opposite as compared to OR gate. Okay. Now, we discuss about the emitter coupled logic characteristics. As compared to TTL, ECL has a faster propagation time ranging from 0.5 to 2 nanosecond, but emitter coupled logic power dissipation is higher as compared to the TTL like 30 MW. The I/O voltage of ECL have a small swing like 0.8. The input impedance of ECL is high or the output resistance is low. Consequently, the transistor change its state very fast. ECL fan out capacity is high and gate delay are low. The advantage of the ECL, the fan out of ECL is 25, which is better as compared to TTL, it low as compared to the CMOS. The average propagation delay time of ECL is 1 to 4 nanosecond, which is better as compared to both CMOS and TTL. TTL thus is called is the faster logic family when the BJT emitter coupled logic gates work in the active region when they have the maximum speed as compared to all logic families. ECL gates generates complementary output. Current switching spikes at not there is in the power supply leads. Output can be coupled jointly to provide the wired on function. The parameters of ECL do not change much through temperature. The number of function accessible from an only chip is high. Disadvantage of ammeter coupled logic: it has an extremely less noise margin, is 200 milliwatt, power dissipation is high as compared to other logic gates. To interface with other logic families, level shifter and necessary fan out limits capacitive loading as compared to TTL. ECL gates are expensive as compared to CMOS. TTL ECL noise immunity is worst. Now, the application of ECL: ammeter coupled logic is used as a logic or interface technology within extremely high speed communication device like fiber optic transceiver, interface, Ethernet, ATM, asynchronous transfer mode network. ECL is the logic family based on BJT, where is high speed operation can be achieved by using relatively small voltage swing or avoiding the transistor from moving into saturation region. ECL is used in making the ASLT circuits within the IBM 360/91. ECL avoids the utilization of stock transistor by using a single ended base IP, the positive feedback between primary and secondary transistors, so attend an inverter function. ECL is used in extremely high speed electronics. Thus, an overview of ammeter coupled logic or ECL circuit, working features, characteristics and application. ECL is very fastest logic family based on BJT as compared to other digital logic families. It attains the maximum speed operation by using a small voltage swing or avoiding the transistor for moving into the saturation region. Integrated injection and logic operation. Integrated injection logic operation is explained as follows. To understand the working of typical I2L gate, consider the figure 5, which consists of 5 transistors connected to as shown. It can be seen that the base current IBI of T1 derived from VCC through the input terminals B, the base bias current IB3 of transistor T3 and the collector current IC1 of T1 are the obtained from the collector current of transistor T2, whose ammeter also connected to VCC. The operating principle of I2L gate: in the latest entry into the bipolar saturated logic field, it uses no biasing and loading resistors at all. Resistors require IOT of power and space on IC chip, hence their elimination results in higher density circuits operating at much reduced power because of its high speed and less power dissipation. It is used a large computer. Another feature of integrated injection logic IIL or I2L circuit is the easy to fabricate. If IB1 is sufficient, the base to ammeter voltage VBE1 or T1 will become the saturation base ammeter voltage 0.8 volt, and this condition is collector to ammeter voltage VCE1 will become saturation base ammeter voltage, the 0.2 volt. So, we find that T1 is in the on state and the output of logic is 0. Since VCES1 equal to 0.2 volt, the collector current IC2 of T2 will flow through the collector of T1 as TC1 and VBE3 of T3 equal to 0.2 volt VCE1. This means that the moment T3 is off and its collector ammeter voltage VCE3 equal to 0.8 volt. Now, the figure 5 is a detail of terminal voltage and current in E2L gate. Now, let the input voltage V1 is equals to 0 volt. This makes transistor T1 to be off state and IC2 to flow through the base T2. Thus, VBE3 equal to VBES3 equal to 0.8 volt. This make VCE1 equal to VBES3 equal to logic 1. The VCE3 equal to VCES3 equal to logic 0. The transistor perform inversion operation within logic 0. VS equal to 0.2 volt. The logic 1 VBS equal to 0.8 volt. This voltage swings of the gate, therefore, V swings equal to 0.6 volt. It can be seen that the logic swing of I2L gate is very low and this is the major defect of these gates. I square L gates of performing single function. This figure 6 show the typical I square L gate performing the single function of logic inversion or anotering. Then the case MOS transistor N1 perform the inversion of input A to produce the output A bar. MOS transistor N performs inversion of the output and the produced again A again. Thus, the circuit shown in figure 6 perform the operation of double inversion. It is the latest entry into the bipolar saturated logic field. It uses no biasing and loading resistor at all. Resistor required of a power and space on IC chip, hence their elimination results in higher density circuit operating at much reduced power. Because of its high speed and less power dissipation, it is used in a large computer. Another feature of integrated junction logic I square L circuit is that is easy to fabricate. Q1 and Q2 are multiple collector transistor and Q3 and Q4 act as a current source instead of resistor as a RTL. The base of Q3 ammeter and of Q1 are tied, so also collector and base, so the makes of the small area on the chip. Case 1, both A and B is low. When the both A and B is low, A low at will be high, bypass the injected current from Q3 and make Q3 off. The input source act as a sink of the current 1. Similarly, Q2 will be because input B is low, voltage at Z will be high. Case 2, either A or B high, both are high. Current 1 I and 1 and 1 2 are both are derived to be junction of transistor Q1 and Q2 and they are turned on. The voltage at Z will be low, being saturated voltage 0.2 volt, thus NOR output is obtained. Now, I square L gates for performing multiple functions. The figure 7 shows multifunction I square L gates that can perform the operations of NOT and NAND and NOR. Notice that only transistor are used. However, an external transistor R may be used to derive the current required for all the PNP transistor from single VCC supply. Notice that the PNP transistor are not are not shown in figure 7. The figure 7 shows the multifunction I2L logic gates. Their transistor T1 and T2 invert input A and B to produce A tick and B tick respectively on collector of T1 and one collector of T2 are now tied together to perform ANDing the produce the NAND output A tick B tick. Using the De Morgans, we find that the operation is also equivalent to the NOR output A plus B tick. The other collector are used to derive respectively transistor T3 and T4, which now invert A bar B bar to give the AND output AB T3. Invert AB is the AB bar. We notice that all logic function can be obtained from logic I2L chip. Advantage of I2L gate: since I2L gates are made up only BJTs, they process high speed operation. Because only transistors are used for the construction, I2L gate have high packing density and are hence suitable for construction of VLSI circuit. Very low power supply requirement, low power dissipation, number of processing step required is small, hence cost per gate is low. Several functions are possible on the same chip. Using bipolar technology, it is possible to combine I2L gates with other logic family. Disadvantage of E2L: very low voltage swings 0.6 volt. The swing is between VBE as 0.8 volt and VCES 0.2 volt. Lower packing density, the NMOS, lower noise margin, external resistance requirement for proper function. I2L technology at present is dormant. Now we discuss about the CMOS. The full form of CMOS is complementary metal oxide semiconductors. CMOS is an integrated circuit built on printed circuit board. It is battery powered memory chip. They effortlessly hold the installation data. The BIOS use the data to turn on the device during the boot up process. The technology makes use both P channel and N channel are semiconductor device. One is the most popular MOSFET techniques available today. It is the complementary MOS or CMOS technology. This is the dominant semiconductor technology for microprocessor, microcontroller chip, memories like RAM, ROM, EPROM, and application specific integrated circuit ASICs, while the N region is the part of the PMOS transistor. The two P region are diffused into the large N region to form the PMOS transistor. The top surface is protected and convert using the silicon dioxide layer SiO2 with aluminum metallization. Now we discuss the CMOS logic gate circuit. Switch level transistor model. NMOS and PMOS transistor are switch on the small or resistance and RON RDS switch of open circuit. The figure shown in the CMOS logic gate. CMOS inverter. Inverter of CMOS value output represent the Boolean expression when x equal to 1, Vx equal to VDD, y equal to 0, Vy equal to 0V. When x equal to 0, Vx equal to 0V, y equal to 1, Vy equal to VDD. Now the general structure of CMOS logic present here. The NMOS pull down network PDN and PMOS pull up network PUN operand by the input variables in a complementary fashion. Working of CMOS. The structure as shown in the consist of the NMOS transistor invented on the top of the PMOS resistor, the substrate of the P type and the N double plus region. The two N double plus region are small and the third N double plus region is large. The two smaller region are part of NMOS transistor. The figure shows the CMOS working. CMOS has the least amount of power dissipation in the switching application. It is because when the transistor is off, the other become on. For the example, if PMOS is on, the NMOS transistor will off. The value of VDD voltage is generally selected between 5 volt to 15 volt. The symbol of CMOS is shown in the figure. Feature of CMOS logic gate: large logic switch, large fan out capability, very high noise margin, lower propagation delay, high speed as compared to NMOS transistor, low power dissipation, excellent temperature stability, less packing density. Now type of CMOS logic gate: CMOS inverter, CMOS NAND, CMOS NOR, CMOS operational amplifier. The figure shows the CMOS inverter switch. The CMOS inverter is formed by connecting the PMOS and NMOS transistors in cascade as shown in the figure. In the CMOS NAND gate, CMOS NAND is the combination of NMOS NAND and PMOS NOR. It consists of the NMOS NAND gate with the PMOS NOR as the lead. CMOS NAND gate can also include PMOS NOR with NMOS NAND is load. That means the NMOS and PMOS transistor combination is the design manner from the CMOS logic gate. The output of the terminal is there in the mention in this slide. CMOS NOR is the, now we discuss about the CMOS NOR. CMOS NOR logic gate is a combination of NMOS NOR and PMOS NAND. The circuit diagram is shown in the figure. Advantage of CMOS logic gate: extremely large fan out capability, lowest power dissipation of gate, very high noise immunity and the noise margin, lower propagation delay than NMOS, higher speed of NMOS, and currently computer chips operating at for more than 4 GHz are available in the open market. Disadvantage of CMOS logic gate: increased cost due to additional processing step, but this is being reflected. Packing density less than NMOS using pass transistor logic structure. Packing density capable to or more than the NMOS gate is possible. MOS chip must be protected from occurring static change by keeping the lead shorted. Static change and accurate in the lead will be destroy the chip. At present, this problem has been reflected by using built-in protective device or circuit. Now this slide we completed the CMOS and I2L. So thank you for this session.